Hey everybody, this is Larry. This is day 28 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem today, whatever. Yeah, what do we have? Today just a minor quick update. Man, marathon season is coming soon. I don't know if I'm ready. But yeah, today just kind of took it easy. I was in the gym just doing my last bench and squats and stuff like this, big lifts, just trying to, before the taper, no more upper body things for a little bit. And then how long did I spend? I did like an hour and a half, something like that. Then another hour of mobility work, just a lot of moving in different planes so that, you keep yourself stable. And then I also spent an hour just cooling down in stretches, both dynamic and static. And then I just ran 5 easy miles. So not that bad today. Taking it easy, taking a rest. That said, I think the Leetcode contest is in like a few hours. I did get home a little bit late, so let's get started. At today's farm. 641. Design circular deck. Design your implementation of the circular double-ended deck. Double-ended queue, which is a deck. You have all these classes, and of course, obviously for this particular problem, what is this circular thing though? Like what part of it is circular? Like are they telling you to implement it as a circular thing? Because like what's the difference between a deck and a circular deck? I'm sorry, friends. I'm just reading right now. Like, what? Honestly, this is kind of confusing, right? That's why I'm trying to look at it for a little bit. The reason why this is confusing is because the thing about these things is that with a data type, in this case, an abstract data type. Oh, I guess this is an abstract maybe. But in general, if you have a data type, what you want to provide is an interface, and for an interface, you want to provide the complexity of, or like the proposed time and space complexity of each operation, right? And as long as you meet that, it doesn't matter what the underlying implementation is, right? That's the part. That is the abstract data type, right? That's the abstract part. You don't need to care about the things under the hood. At least in theory, obviously, because sometimes there are some like poor performance issues, and then maybe as a third party, you have to at least think about it. But in any case, in general, that's not something that you need to think about. And I don't even know what the circular part refers to. Honestly, is what I'm trying to think. This is just a regular deck, right? And of course, for this video, for this problem, we will not use the Python stack library, because that's just silly if that's the case, right? Oh, I guess it could be 4. It has a max size of k, but I still don't know what the circularness is. Because unless they want us to be very specific about this, right? Like about the implementation, like, hey, implement it this particular way. It's kind of an odd problem and an odd ask, but I guess that's fine. But there's nothing that I'm trying to read through a few times that tells me that there's nothing that tells me that this is honestly that requires a circular implementation, I suppose. We'll do our best to implement it with a circular array or whatever, but that is just a very weird problem as a result, honestly, at least for my part. If you're one of those engineers that just do what they're told, then I guess it's not that bad. But anyway, so maybe we just have an array. We maybe just call it none, right? Maximum size is k. Let's just say we have k times 2, just because I'm lazy. about dealing with things. Right, oops, why am I doing that? But yeah, so now we can do something like this, right? Not a big deal, and that's really it, right? And then because everything else, like the number of things used, we can be based on this, and everyone we just put in this, right? Let's start with is empty, right? Then return self.right, oops, I don't know how that, self.left is equal to 0. Yeah, I mean that sounds I guess it really depends on how you want to phrase it, right? Then here this means that what does this mean? This means that oops, left is inclusive, right is exclusive, right? So that's basically what this means. And as long as we kind of are consistent about it, we should be good. Left is inclusive, right is exclusive, or what they call half open, I suppose, right? And its full is with self.right minus self.left is equal to self.k. I guess we have to store it in k. Yeah, right. And yeah, I mean, we don't really, I don't know, I just like it, you know. I guess you don't have to save this if you want to reuse this length or whatever, but that's just, it's like an extra couple of bytes, it's fine. Right, so get front, yeah, right, so if self.dot is empty, then we return -1. Otherwise, we just return self.array, self.left. Should be good, right? Same with get rear, right? And self.array, self.right -1, right? Keeping in mind that they're inclusive. But also exclusive on this part, sorry, on the right side. And also that if it's empty, then it's good. There's one thing that we need to do, though. And the reason why I write it this way as a lazy circular thing, even though it doesn't come up yet because we haven't done these yet, is that we do want to actually do a circular part, so we can actually just mod it by yeah, this length, which is not exactly k. It is not the way that we write it. It probably works if the array is exactly k, but I just want to be lazy, honestly. And not dealing with possible edge cases. There might not be edge cases, but I don't want to deal with possible them, right? So insert front is pretty straightforward. So self, we want to say, you know, self dot. So left is already inclusive, so we have to go to the left one, right? And yeah, and then now there should be a none. Otherwise, oh, I guess we have to if self dot is full, then we just return false, right? Otherwise we can always do this. So then now you have self dot left and self dot array is equal to value, and we return true, right? And so last is same ish, right? Self dot is full, and the reason why we can just to kind of go over why we can do this is that we have all these invariants, right? Because if it's not full, that means that always this bound holds, which is that left is inclusive and right is exclusive, in a mod circular kind of way, right? And you can't really catch up all the way, because if you catch up all the way, then it's going to be it's full, right? So yeah, that's basically the idea. And I know it is a little bit more expensive to do a mod on every operation, but it is also just a lot easier, right? Because if you think about it, you know, because then if you mod before you store it back to left, or do a soft mod, meaning if it's greater than n, subtract n or whatever, thing is that now you have a lot of edge cases to kind of deal with. Maybe it's not even that bad, but why if you don't have to? In this case, because it is exclusive, we can set it first and then we have to increment it, right? And because we don't do mod, this is where, oh, this should be mod though. I mean, we don't do mod as we do it, we do mod only on SS. It allows us to have these things just very simple. and also helps with debugging, I think, at least to me, because, well, these mean very specific things, right? Very easy to understand things in an infinite array kind of way, even though it's not, right? So if self dot is empty, then we return false, right? Otherwise, we delete front. So front is inclusive, so we can delete it immediately first. And then we increment it back, right? You probably don't even need to set it to none, but in theory, for debugging purposes, then it just becomes a little bit clearer. And you could do it without it. I don't know if it matters that much. But yeah. And then now on the right side is exclusive, so you have to subtract one first. But yeah, this is why I generally don't like doing an exclusive balance, because not because it's hard, but you just have to think about it every time, and you have to be careful every time, right? So that's basically it. Yeah, pretty straightforward. 1642-day streak. For science, let's see if we could have done it with K. I think this should still be good, but I just wanted to not have to think about the whole invariant thing. Here, instead, we just have a buffer, right? So, and yeah, not that much of a big deal. Yeah. What's the complexity here? Well, everything is O of 1 as far as I know, right? As far as I can tell. This is O of 1, this is O of 1, 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 O of 1. So everything's O of 1. And then the question is, what if you don't... The question that I might start with is, what if you don't have K and you just kind of, you know, and it doesn't allow you to get 4, which is a regular Deque implementation instead of a K Deque. This is... The circleness is kind of weird, because you probably just want to call it a K Deque and not a circular Deque, and let people decide. And maybe in that case, I might have done like a linked list or something. Honestly, that was my first thought, but I don't know. But yeah, if there's no K, then actually, you know, that is just a regular Deque, and the only thing that is different is that its 4 is not going to be there. Obviously, everything else looks roughly the same. The only difference is that when you insert. And it gets too full, or maybe 80% full. I forget what the magic constants are. But if it gets full enough, then you reallocate your memory to double, right? So the repeat doublings, if you do the math, is amortized constant. So that's basically why people do it. And of course, on deletion, you also, if it's under some load factor, you'll also shrink the memory and give it back. Also, all of 1 amortized per cell. So that's why it is a popular thing. But in this problem, we don't really need to do it. And yeah, that's all I have for today. That's all I have for this one. Let me know what you think. Thanks for watching. Yeah, stay good, stay healthy to good mental health. I'll see y'all later. Take care. Bye-bye.